Importance of magnetic information for neuronal plasticity in desert ants. Authors: Robin Grob, Valentin L. Muller, Cornelia Grubel, Wolfgang Rossler, Pauline N. Fleischmann. Published in PNAS, Volume 121, Number 8, February 12, 2024. DOI 10.1073/PNAS.23207642121. This study explores the role of the Earth's magnetic field in the navigation and memory formation of Cataglyphis desert ants. The researchers manipulated the natural magnetic field at the ant's nest entrance to observe its effects on neuronal plasticity. They discovered that magnetic information is integrated into the ant's internal compass, the central complex, and learning and memory centers, known as mushroom bodies. The findings indicate that magnetic cues are essential for calibrating the visual compass and forming spatial memories, demonstrating that ants use magnetic information both for navigation and as a reference system for visual compass calibration. The research highlights the critical role of magnetic fields in the neurological development of ants, and raises questions about the impact of electromagnetic interference on natural navigation systems. In the ever-evolving landscape of wireless technology, the unseen consequences of electromagnetic interference, often referred to as entropic waste, are beginning to surface. A groundbreaking study published by PNAS reveals that desert ants utilize the Earth's magnetic field as a navigational compass and a reference system for visual compass calibration. This revelation prompts an urgent examination of how wireless technology may disrupt these natural systems. Understanding magnetic information processing in desert ants. Desert ants, specifically Cataglyphis notus, rely heavily on the Earth's magnetic field for navigation. The study shows that these ants integrate magnetic information into their internal compass, known as the central complex, and learning and memory centers, called mushroom bodies. This integration is crucial during the ants' learning walks, a period when naive ants calibrate their celestial compass by performing specific navigational behaviors around their nest entrance. Neuronal plasticity and magnetic cues. The study revealed significant structural changes in the neurons of the central complex and mushroom bodies when ants were exposed to manipulated magnetic fields. These changes indicate that magnetic information is not only a navigational aid, but also a key element in spatial memory formation. This finding underscores the complexity and importance of magnetic cues in the neurological development of these insects. Significance of entropic waste from wireless technology. Definition and sources of entropic waste. Entropic waste refers to the byproducts of energy consumption that increase entropy, including electromagnetic emissions from wireless devices. These emissions create electromagnetic interference, or EMI, which can alter the natural geomagnetic field that many species rely on for navigation. Potential impacts on navigation systems. Electromagnetic interference from wireless technology could disrupt the delicate balance of natural navigation systems. For species like desert ants, birds, and marine animals that depend on geomagnetic cues, such interference can lead to disorientation, impaired navigation, and ultimately, threats to their survival and reproduction. Potential consequences on biodiversity. Impact on various species. The reliance on geomagnetic fields is not unique to desert ants. Migratory birds, sea turtles, and bees also use these fields for navigation. Disruptions in these natural cues due to electromagnetic interference could lead to catastrophic consequences for these species. For example, migratory birds may veer off course, leading to exhaustion and increased mortality rates. Broader ecological implications. The disruption of natural navigation systems can have ripple effects throughout ecosystems. Predator-prey dynamics, reproductive success, and habitat use can all be impacted by species' inability to navigate effectively. This can lead to decreased biodiversity and altered ecological balances, affecting the health and sustainability of ecosystems. Case studies and supporting evidence. Migratory birds. Studies have shown that migratory birds use the Earth's magnetic field to navigate across continents. When exposed to electromagnetic interference, these birds exhibit disoriented behavior, often leading to fatal consequences. The implications of these findings suggest that electromagnetic pollution from wireless technology could severely impact migratory patterns and bird populations. Marine species such as sea turtles rely on geomagnetic cues for navigation during long migrations. Interference in these cues can lead to misplaced nesting sites and reduced reproductive success. The long-term effects on marine biodiversity could be profound, as disrupted navigation affects entire populations. Addressing counterarguments and research gaps. Some studies suggest that low-level electromagnetic fields have minimal immediate impacts on wildlife. However, these findings often do not consider long-term exposure and the cumulative effects of electromagnetic pollution. More comprehensive research is needed to fully understand the scope of these impacts. Need for comprehensive studies. Current research gaps highlight the need for long-term studies that assess the effects of electromagnetic interference over multiple generations and across different species. Understanding these impacts will require interdisciplinary approaches that combine field studies, laboratory experiments, and advanced modeling techniques. Conclusion. The preliminary findings on the impacts of electromagnetic interference on natural navigation systems call for more focused and comprehensive research. Long-term studies are essential to ascertain the full extent of electromagnetic pollution's impact on wildlife and ecosystems. Policy recommendations. To mitigate the potential impacts of wireless technology on natural navigation systems, it is crucial to develop and enforce guidelines that limit electromagnetic emissions in critical wildlife habitats. Additionally, advancing technologies that minimize electromagnetic spillover and designing wildlife-friendly wireless technologies are imperative. Appendices. Detailed study findings. Key findings. Desert ants integrate magnetic information into their central complex and mushroom bodies. Manipulated magnetic fields cause significant structural changes in neuronal circuits. Magnetic information is crucial for navigational calibration and spatial memory formation. Glossary of Terms. Entropic waste. Byproducts of energy consumption that increase entropy, including electromagnetic emissions from wireless devices. Geomagnetic field. The magnetic field that extends from the Earth's interior out into space, guiding various species in navigation.